Welcome to Maths Academy 2. Today I have some selected problems on mathematical reasoning. So in my problem solving, I will focus on logical connectives, compound propositions, argument and validity, and quantifiers. So I will try to address these 4 issues in the problem solving. So I need you to pay attention for this video. So the first problem is, suppose the proposition P implies the negation of Q is false, then which of the following is true? So let us use the given information, then we will try to answer accordingly. So given that P implies the negation of Q this is false. Here we need to know the rules in compound propositions. The only case that gives false, the implication that gives false is only true implies false is false. The rest, any possibilities are true. So the only case that gives false is true implies false. So here P must be true. P must be true, and the negation of Q must be false. So here P is necessarily true, and the negation of Q is false. This implies P is true and the negation of Q is false, means Q is also true. So from the given information we have this thing. So based on this information we will identify a compound proposition which is true. So let's see the first choice. The negation of Q and P implies Q is this means Q is already true. Therefore, let us put the truth value here. The negation of Q and P is true, and Q is also true. Using conjunction, true and true is true. So this is equivalent to this one is false, false and true. This is false. False and true is false. So A cannot be the answer. It's not a true statement. Let's check for the B case. In B we have the negation of P or Q implies the negation of P. So we have P is true, Q is true. So let us use this truth value. The negation of P, which is true, or Q implies negation of P. So let us evaluate this thing. The negation of true is false, or true implies the negation of true is false. We know that true implies false is false. This is false. Here we have false. False or false is false. So B is not a true compound proposition. Let's check for C. Let's check for C. In C we have negation of Q or P. Negation of P or Q. Negation of Q or P by implies Q. So let us put their truth value. The negation of Q means true, or P is true, by implies Q, which is true. So this is the same as false or true, by implies true. False or true is true. True by implies true. true is true. So the statement, the compound proposition in C is a true statement. So we expect our answer to be C. Let's check for D. In D we have P and Q. P and Q by implies the negation of Q. So let us substitute the truth value according to their position. P is true and Q is also true. By implies the negation of Q, which is true. The negation of true is false. By implies true and true is true. Now true by implies false is false. During by implication, both must be true or both must be false to get true. So still D is also false. So our answer for the first problem is C. Suppose E is a proposition that represents an even number, even natural number. P is a prime number. D is a number divisible by 2. Which one of the following has a truth value false on the set of natural numbers? So we are going to evaluate these quantifiers. So the question is, we are asking which of these compound propositions containing quantifiers has a truth value false. So let's check for the A case. In A, there exists a natural number x. There exists a natural number x which is even and prime. Yes, there exists. For example, you can take x is equals to 2. This is even. At the same time, this is prime. Therefore, there exists. So this is a true statement. The choice in A is true, but we are searching the false truth value. So let's check the B case. In B we have for every x, the number is even implies it's divisible by 2. For all x, for all natural number x, if the number is even, then it's divisible by 2. This is true. So the compound proposition in B is also true. Okay, this is true. Let's see the other choice. The choice in C, there exists a natural number x which is even and not divisible by 2. The negation of D means, since D is a number divisible by 2, the negation of D is not divisible by 2. So there exists a natural number x which is even and not divisible by 2. This is wrong. This is false. There is no natural number which is even and not divisible by 2. So the false statement is this one. This is false. So we expect C to be the answer. Let's check for the D case. In D we have for every x, the number for every x means for every natural number, x is even or not divisible by 2. That means every natural number is even or odd. There is no more option. So this is also true. The choice in A, in B, in D are true, but the statement in C is false. So we are asked the false statement, so our answer will be C. Let's P, P, Q, and RB propositions such that P implies R or negation of Q is false, then which of the following proposition is true? So to know the true proposition, we need to use the information that is given as P implies R or negation of Q is false. Means if this compound proposition is false, automatically this part should be false and this part should be true. There is no more other option than this. So P necessarily be true. P must be true. P must be true. And R or negation of Q must be false. Okay, so this will be false if both R is false, and negation of Q is false. Okay, negation of Q will be false whenever Q is true. So we have the information about P, Q, R. Now we have P is equals to, or P is true, Q is true, and R is false. We will have this thing from the given information. So based on this, let us see the choice in A. The choice in A is P implies R, but P is true, R is false. True implies false is always false. So A cannot be a true proposition. Let's check for B. The negation of R implies Q. The negation of R implies Q is equivalent to the negation of R is false. R is also already false. The negation of false implies Q, where Q is true. Now this is the same as the negation of false is true, implies true. Now true implies true is true. So immediately our answer will be B. We can check that the rest will be false. We can check, let's see the compound proposition in C. The negation of P by implies Q. Now this is the same as the negation of P is true, implies Q, where Q is also true. So this part is false, by implies true. During by implication, both must be similar, both must be false or true to get a true result, but here it's false. So C cannot be the answer. Let's check for D. In D, Q by implies R. That means Q is true and R is false. Here this is false. So the only true compound proposition is the statement in B. If P or Q implies the negation of R and R is true, then which one of the following is necessarily true? So first let us put the information here. It's given that P or Q implies the negation of R and R. This is given as true. This compound proposition is true. Then which one of the following is necessarily true? Here we need to be very careful. The negation of R and R is false. This is false. For any proposition P P and the negation of P is false. Okay, P or the negation of P is true. Okay, we need to know this fact. So let us apply this thing. This part is false. Okay, P or Q must be false. So if P or Q is false, this implies both P and Q must be false. There is no more option than this. P or Q is false implies both P and Q are false. So we will apply this fact to determine which of these compound propositions are false. Let's check for the first one. In A, P or Q implies Q means P is already false and Q is also false, implies false. Okay, so this is false, or false is false, false implies false, which is true. Therefore this is necessarily true. The compound proposition in A is necessarily true. You don't need to check the other thing. So if you want to know how this can be the answer, negation of Q and R, negation of Q and R, this is the same as negation of Q is false and R. Okay, negation of false is true, and R is dependent on R. If R is false, it becomes false. If R is true, it becomes true. So this is not necessarily a true compound proposition. Okay, so B cannot be the answer. Let's check for C. Negation of P by implies R. Negation of P means negation of false by implies R. Now negation of false is true. True by implies R is dependent on R. If R is true, the compound proposition becomes true. If R is false, it becomes false. So we cannot draw any conclusion here. So C cannot be necessarily true. In D, the negation of P or R means the negation of false or R, which is true or R. So true or R is true whatever R is. R can be true, R can be false, whatever the case, this is true. So here we could get A and D are the answer. By chance there are two answers for this problem. Which one of the following is a valid logical argument? So we will evaluate the following arguments. So the choice in A is P implies Q and Q are the premises in A. The conclusion is P. Let us evaluate this thing. The premises are always true. Okay, the premises are always true. Q is true, P implies Q is true. So P implies Q is true and Q is true. Okay, so this compound proposition will be true whenever this compound proposition can be true whatever P is. P can be false, P can be true because Q is true. Look, P implies true is true whatever P is. So we cannot draw any conclusion from this argument. there are possibilities for P to be true, to be false. So the argument in A is not valid. So let's check for B. In B we have P implies by implies Q, and P implies Q. These are the premises, and the conclusion is Q. So the premises, as I have told you before, the premises are always true. So true implies, P implies Q is true, P by implies Q is true. So from these premises, P and Q can be both true, both can be true, they can be false, both of them can be false. Okay, so there are such possibilities for P and Q. So since Q has different possibilities, we cannot draw any conclusion about the validity of this argument. So B cannot be a valid argument. We cannot draw any conclusion from the given premises. Let's check for C. The negation of P and Q implies R. These are the premises, and the conclusion is R. So put the premises as true. This is also true. But let's take the first premises. The negation of P and Q is true means the negation of P and Q is true means both negation of P and Q must be true. So Q must be true, and the negation of P is true. True and true is true. No more other option. So negation of P is true means P is necessarily false. P is necessarily false. Now let us use the second premises. Let us see. Q implies R is true, but Q is already true. Q is true. So true implies R is true means necessarily this implies R is necessarily true. If R is false, the premises will not be true. So R is true means the conclusion is true. Therefore, this is valid argument. The choice in C is our answer. C is our answer. We can check that D is invalid, or we cannot draw conclusion from the premises. So let us see in D, the negation of P or Q and R implies Q. These three are the premises, and the conclusion is R. So the negation of P, this must be true. P or Q must be true. R implies Q must be true. Negation of P is true means P is false. Negation of P is true means P is false. If P is false, let us see P or Q. This is true. Already P is false. False or Q will be true. False or Q will be true whenever Q is true. Q is necessarily true. Q is true. Okay, let us use the third premises. Q is true. So R can be anything. R implies true is true, whether R is true or false. So we cannot draw any conclusion from these premises. So our answer will be C. Which one of the following is equivalent to the given quantifier? The negation of for all x P implies Q. here there is a rule for the negation of quantifiers. Okay, the rule is the negation of for all x A implies B means this is equivalent to there exists x which is not A implies B. Okay, or you can equivalently write this thing as there exists x which is the negation of A implies B means the negation of A or B. So again, this can also be expressed as there exists x which is A and the negation of B. You can distribute this negation into bracket. The conjunction reverses to the disjunction reversed into conjunction, and the negation of negation will be the proposition itself. So these two are equivalent. The negation of for all x A implies B is equivalent to there exists x satisfying A and the negation of B. So based on this principle, the negation of for all x P implies Q is equivalent to there exists x. You can distribute the negation into the bracket. There exists x. The negation of P implies Q. Okay, so the equivalent compound proposition for P implies Q is equivalent to negation of P or Q. Okay, so this is the same as there exists x satisfying the property P and the negation of Q. So this compound proposition is equivalent to the negation of universal quantifier for this compound proposition is equivalent to this one. Therefore, from the given alternatives, the answer will be D. For arbitrary propositions P and Q, which one of the following is valid equivalence? So let's see the choices. In A we have the negation of P implies Q. The negation of P implies Q is equivalent to Q implies P. Sometimes we need to be very technical for a certain compound propositions which we don't have its equivalence. We need to be very technical. Here, you can assume P and let's take P and Q as a false proposition. Okay, if I take this thing, the compound proposition in A becomes the negation of false implies Q, which is false, is equivalent to false implies false. Basically false implies false is true. This is true. Okay, the negation of true is not equivalent to true. The negation of true is false. False is not equivalent to true. So A cannot be the answer. A cannot be a valid equivalence. Let's check for the compound proposition in B. In B we have the negation of P implies Q. The negation of P implies Q and P. Is it equivalent with P and negation of Q? Let's check it. Let's check this equivalence, P and negation of Q. So let's take the first one. Let's take this one, what it looks like. The negation of P implies Q is always the same as the negation of P or Q. This is one of the equivalent proposition that we need to know. So in place of P implies Q, I will replace the negation of P or Q, okay, and P. Now distribute this negation into the bracket. Then the negation of P is P. The disjunction becomes conjunction. Okay, then this negation will change the sign of Q. Therefore, P and negation of Q. Therefore, when we simplify this part, it gives P and negation of Q. They are the same. So the compound proposition in B are valid equivalents. They are the same. So let's check the C and D case. In C, we do have P or Q, P or negation of Q is equivalent to P implies Q. Let's check this one. If you take P implies Q, P implies Q is equivalent to the negation of P or Q. Okay, so this is the negation of P or Q, but this part is P or negation of Q, which is different. So this is not a valid equivalence. Again, let's check for D. In D, simply if you take P and Q as true, if I take P and Q as true, true or true implies true. If they are valid, this must be true. This must be equivalent to true implies the negation of true. Actually, this part is true, but this part is true implies false, which is false. So this is false. So the compound proposition in D is not valid equivalence. So our answer will be B. If each of the compound propositions, if each of these compound propositions P or Q, P implies R, and negation of R is true, then which one of the following is true? So let us write properly what is given. Each of P or Q is true. Okay, the other thing is P implies R is true, and the negation of R is true. The negation of R is true implies R is false. R is false. If R is false, now take this part. If R is false, P implies false is true. Now this holds whenever P is only P must be false. Otherwise, the given truth value will fail. Now R is false, P is false. What is left? We need to know Q. Okay, P or Q is true means this implies P or Q is true. I mean here P is already false or Q is true means this Q must be false. I mean this Q must be true. Otherwise false or false will be false. So this implies Q is necessarily true. Okay, we have determined R is false, P is false, Q is true. So which one of the following is true? P is not true, P is false. Q, yes, Q is true. Q implies P means Q is true. True implies P is false. True implies false is false. Okay, so this cannot be true. P is already false. False and the negation of R means true. False and true is false. So the only true case is B. Which one of the following compound proposition is a tautology? A compound proposition is a tautology if all the truth values is true. So let us take the compound proposition in A. In A we do have Q, Q or the negation of Q. The negation of Q implies P. Okay, here for any proposition P, Q or negation of Q is always true. True implies P is dependent on P. The truth value of this compound proposition is dependent on P, meaning that if P is false, the output will be false. If P is true, the output will be true. Therefore, we cannot say that the compound proposition in A is a tautology. So there are mixtures of different truth values in A. So A cannot be our answer. Let's check for B. In B, we do have P implies Q, Q or the negation of Q. Okay, always Q or negation of Q is true. Okay, so P implies true is true whatever P is. If P is false, it's okay. False implies true is true. If P is true, still it is true. So this compound proposition in B is a tautology. So we can check that the rest are a contradiction. So let's check the case in C. In C we have P or Q, Q and the negation of Q. Okay, here Q and the negation of Q is false. Okay, this is always false. We take P or false is P. P or false will be false whenever P is false. It will be true whenever P is true. Therefore, it depends on P. So we cannot say that the case in C is a tautology. So C cannot be our choice. D, P implies Q and negation of Q. Look, this is false. Q and the negation of Q is false. Okay, so P implies false. Still, it depends on P. If P is false, the output will be true. If P is true, the output will be false. So the compound proposition in D cannot be a tautology. Therefore, our answer is B. If the truth value of the proposition P is false, the truth value of P is false, then which of the following compound proposition has a truth value true? What is given here is the truth value of P is false. Okay, so which of the given choice has a truth value true? In A, negation of P and P means negation of false and false. Negation of false is true. True and false is false. So A cannot be the answer. In B, negation of P implies P. This is the same as negation of false implies false. This is the same as true implies false. True implies false is false. So still B cannot be the answer. Let's proceed to C. In C, the negation of negation of P, or P means this is the same as the negation of false or false. Negation of false is true. Negation of false is true. True or false. Basically, true or false is true. This is true. The negation of true is false. So the choice in A is false, in B is false, in C is false. We expect D to be the answer. So P implies the negation of P means P is false. False implies the negation of false, meaning that false implies true. This is definitely true. Therefore, the answer for this problem is D. All the rest in A, in B, in C, they are false. So the answer for this problem, or a compound proposition having a truth value true, is the case in D. What is the contrapositive of if X is an element of natural number, then X is an integer and X is greater than 0. Here, before going to the answer, we need to know what a contrapositive is mean. Suppose we have a certain compound proposition with P implies Q. With P implies Q, its contrapositive is, the contrapositive of P implies Q is expressed as the negation of Q implies the negation of P. So if we know this thing, it's very simple. If X is an element of natural number, then X is integer and X is greater than 0. The contrapositive of this statement is if X is not an integer, or X less than or equals to 0. Here it is greater than 0, therefore we take the reverse. X less than or equals to 0, then X is not an element of integer. So this is exactly the contrapositive of the given compound proposition. Therefore, from the choice, our answer will be B.